Hi everybody, and good afternoon. So, thanks for having me. It's been really interesting to be here. I've seen lots of talks over the last day and a half, but none of them have really mentioned the natural environment or geology, so I'm going to change it all in one talk. I apologise, this is a younger version of myself in the corner there. That's me pre-mortgage, marriage and kids, so I can find a better photo. So today I'm going to talk about making geology relevant for infrastructure and planning. In this talk, I'm going to talk a little bit about BGS and what we do, and what I do at BGS itself. I'm going to talk about the Translucent Cities projects that we did with the University of Cambridge just over a year ago. And then I'm going to show what we can do for you. So I'm going to show you a few areas of the BGS website, essentially, where you can get data yourselves. So, who are the BGS and what do we do? So this is, well, I apologise not knowing this off by heart, but this is the official BGS tagline. So BGS is a component body of the Natural Environment Research Council. It's the nation's principal supplier of objective, impartial and up-to-date geological expertise and information for decision-making for governmental, commercial and individual users. The BGS develops the nation's its geology to improve policy making, enhance national and reduce risk. It also collaborates with the national and international scientific community in carrying out research in strategic areas, including energy and natural resources, our vulnerability to environmental change and hazards, and our general knowledge of the Earth system. So in a nutshell, we do everything from a macro scale to a nano scale in hydrogeology, geochemistry, geotechnical, working in urban areas, which is what I do a lot of now. And my role at BGS is to create 3D representations of geology using geological modeling software. And I do a lot with visualization of these 3D geological model this software as well. So I'm going to give you a few examples of that. So the main example I'm going to talk about is Farringdon Station, a project I worked on like 8-9 years ago. And this is a project we did in collaboration with Dr. Zauer Group for Crossrail. In this, we created a conceptual geological model down to about 50 meters below ground level to inform the construction of this station itself, Farringdon Station. This is a special case because much of the London Underground is built within the London clay, which is a nice homogeneous, nice medium. In this case, in Farringdon, it goes into the unit below, which is called the Lambeth group, which is really variable and contains sand lenses, so there's perch aquifers. So it's a bit of an engineer's nightmare. Can you play the video, please? Just click on the picture. And then, but not to worry. So basically what we did was hand over that model to Dr. Zauer Group, and they was able to improve on that model by as the tunnel boring machine was going through, they was able to draw mini sections that were added to the model to increase the prediction, the knowledge of that geological model. So there was lots of benefits associated with this. They was able to do borehole prognosis in and around the station, do horizontal slices, do vertical slices, and do predictions of the geology. In turn, this produced like a 70% reduction of in-tunnel probing from that was originally planned. It supported more efficient spray concrete line design for 5 additional tunnels. It enabled the construction of 2 9.5 meter wide tunnels without a pilot, and 5 openings without additional reinforcement or thickening. So we're saving lots of money and lots of time here by knowing more about the geology. So a lot of it's to do with construction. And just other examples, we worked on HS2, created a 500 kilometer corridor around the HS2 route to do similar things. This is for the electrification of the railway between Leeds and York, so they can improve the pile design. This is artistic license on the Monmouthshire and Brecon Canal. It doesn't actually look like anything like that, but that was to remediate some of the areas along that canal. And we can take in a plethora of data. We can take in laser scans, we can take in a CAD model, and any types of data that you can provide us. So this leads me on to the Translucency project. So this was done in collaboration with the University of Cambridge. Started in 2018, October 2018. It ran for around 6 months. This was as a result of one of my colleagues, Steph Bricker, talking to Rushi Chowdhury about combining geological data with and building typology data, and how we can make or harness the value of the subsurface but make it sustainable for future generations. And we applied for some innovative funding, which was one, and it was basically an industrial placement. So myself and 2 colleagues, Steve Thorpe and Holger Kessler, spent a couple of days a week, every week for 6 months at the CSIC offices in Cambridge, kind of sharing our knowledge of the geology. The research was split into 2. Study 1 was about a kind of broad brush land viability exercise. So we've got a model that covers the whole of London and beyond, called the London and Thames Valley Geological Model. And this was looking at using cluster analysis and PCA to with land use type, population statistics, that kind of thing. And then we had a kind of much more focused study in the in the Kensington and Chelsea borough. And this was looking at the impact of subsurface infrastructure and basements on ground properties and geothermal. I'm pleased to say one of the collaborators, Asel's in the room, so she'll answer any questions about that later on. So we didn't want to just give the geology to the guys at the University of Cambridge because they wouldn't know what to do with it. So we wanted to give them attributed geology. So part of what we do at BGS is derive products from our base geological map by adding information and attributing it with different information. So it could be groundwater information, it could be aquifer designation, depth to groundwater. These are all national coverage as well, so we've got it over the whole of the UK. Bedrock permeability, superficial deposit permeability, etc. So they're hydrogeological parameters, but we also added kind of geotechnical parameters as well to the geology. So we're talking about strength, corrosivity, foundation conditions. So we have these all in map form on national coverage, but we don't necessarily have these in 3D. So that part of the project was to produce a layer that could be used in the 3rd dimension, in the subsurface. So instead of providing this like geological sandwich, I'm going to call it, to Asal and others, so we've got in the brown unit there's the London clay, we've got the orange unit, it's the Lambeth group, and above that we've got some terrace deposits, some gravels and alluvium. And this is the borough, Kensington and Chelsea there. We didn't want to provide this like geological layer cake sandwich because they wouldn't know what to do with it. We wanted to provide something that was more meaningful. So what we did is use a bit of Python script to actually slice and dice the model and vectorize the model into kind of a GIS format. So for each layer, so we start at the surface and we go 1, 2, 3, 4, 5, 10, 15, 20 meters below ground surface. So like the zone of human interaction, so to speak. We sliced and diced the model and linked our model in a kind of GIS format. So, and this was all based on the type of geology. So we used something called Lex RCS. Lex is the formation name, like London Clay or Lambeth Group. And then we have the RCS code is what that unit is made up of: clay, silt, sand, gravel. And once you've got the key, you can start linking it back to the attributes that I've just mentioned. So then for each cell, we've got the geology at each of those depths. And then we've got the attribution, say, of foundation conditions, or in this case, the volume change potential. So this is to do with shrinking and swelling of clays, hazard. It's a big hazard in London, it causes lots of subsidence. So you can see VCP 0 meters on the left there. That's at surface, volume change potential at surface, and then we've got the volume change potential at 5 meters below surface. So it's markedly different. And likewise, we did the same for foundation conditions. So we've got foundation conditions at surface there, and then the foundation conditions on the right, 5 meters below ground surface. And then all of these items you see in the legend can be linked back to our databases or reports that gives you more information about the ground conditions and what you should be aware of. So this is how we kind of mitigate against hazards in the subsurface. So instead of just giving a geological sandwich, we've deconstructed that to give the bits of sandwich that they want to have for their piece of work. Pretty much what my sons do on a daily basis. So study 1, land viability. Like I said, Mingdo Huan, he did cluster analysis and PCA. Initially, just looking at population statistics and land use, but I know he's looking more and more into geology now, but he's getting his head around how this would work on a kind of greater London Authority scale. But one idea is to look at fuel poverty and how we can use geothermal to remediate that. The second study was a lot more focused, like I said. It was in the borough of Kensington and Chelsea. And within that borough, we were looking at basement structures. So we picked 3 areas within this borough that had a similar amount of basements, but markedly different geology. So in the case study 1, we're looking at 10 meters of gravel on top of the London clay. Case study 2, we're looking at 5 meters of gravel on top of the London clay. In case study 3, it was London clay was at surface. It was all London clay. And ASL was able to use finite element modeling to actually show the propagation of heat over time in each of these cases. And as you can see, there's quite a lateral change depending on the hydrogeological flow and the groundwater properties, and plus the geology in these different areas. So in case study 1 is a much more laterally spread horizontal flow, while in the London clay is much more vertical. And this we see is something that we can extrapolate over the whole of London, for example. So what we're showing here it is possible to bring together but disparate but physically linked data to harness via the subsurface for future planning and ground investigation. ASL has just submitted a paper on the more focused study to the Journal of Tunneling and Underground Space Technology, but we are going to continue to work together. We do have lots of data available to you. We work for, well, you can use this for free if you're non-commercial or research, and we do provide consultancy, and we're open as well. One of these data-rich areas that you should look at is this UK GEOS, UK Geoenergy Observatories. There's 3 sites: Cardiff, Thornton in Cheshire, and in Glasgow. In Cardiff, we're particularly looking at geothermal. There's over 6 million measurements available over 4 years. In Thornton, we're going to be drilling 100 boreholes. I'm going to put thousands of sensors down in those boreholes to measure the subsurface. So from the talks I've seen for the last half, it'd be really useful to have some of you guys on board. And then in Glasgow, we're looking at the mine water and geothermal mine waters. And this, yeah, I need to look on the UK GEOS website. However, generally, BGS has millions of records, millions of data measurements available to you. If you go onto the Open Geoscience web page, you can see where all our data portals are, where you can get some data downloads. There's apps, so we've got modeling apps, we've got apps that you can download on your phone, such as iGeology or MySoil. We've got over 1 million whole data scans available for free. You can use that now. The main portal I would encourage you to use is this GeoIndex. So we do onshore and offshore, macro scale, so you can get stuff on gravity, or you can get stuff on the micro scale at geochemistry. So I would encourage you to look at that. And you can also contact our inquiry service to get more data. And we do have a national geoscience data center where we actually store data, both analog and digital, but we encourage you to store digital data. So site investigations, for example. This once we've stored that is open to everybody to use as well. So we're kind of trying to get rid of data redundancy and duplication in the future. And there's initiatives that we're running, such as Dig to Share, which is encouraging environmental consultancies to actually donate their borehole data in AGS format to the BGS, so for everybody to use. So if you do have any data, please contact us. that's it. Thank you for listening.